everybody, fan and people like that have joined before, and hello to the people that are new and joining. Really, really good to see you here today. So just to give you a bit of an introduction to Matt, and I hope I do it justice, Matt. So this is from my own research and what I know about you so far. So Matt, who joins us today, comes from security and platform automation background. He spent nearly 9 years working at Cisco with infrastructure and cloud platform teams, which I thought was quite impressive in itself. Cisco being the big monster that it is. Interestingly, though, later on working for the developer experience team, so supporting and promoting all of the developer ecosystems. So that's how I really got to know Matt, through that kind of developer advocacy route as well. So it's been now, what, 8 or 9 months since joining Bridgecrew, and today talking here about infrastructure as code, security, and Kubernetes. So automating deployment best practices.
Cisco kept offering me kind of interesting technologies to work with and things like that, so it flew by actually. But it is crazy when it's put into 8 years perspective. But yeah, on to kind of bigger and better things and Kubernetes and security. So like I'm massively interested in Kubernetes from a future of kind of distributed compute, edge computing perspective anyways. And I also kind of love the way it kind of brings together cloud providers and kind of provides that, portability style API. And obviously I've always been passionate about security anyway. So it kind of combines two of my favorite things in this space, you could say. So let's get straight to it. I would absolutely love it if people kind of ask questions, either on the chat or, ping it to Joe, and I'm sure he'll interrupt me. Love to have it a little bit informal, a little bit conversational, and make sure everyone gets something out of this. So hi everyone, and again, thanks Joe for having us on today. So yeah, quick shout out from what Angela was saying. We are giving away swag for people that are really missing conferences and things. So if you want kind of some Bridgecrew swag, the link is there below. I will just leave this up for a second. If you want to carry on this conversation with me afterwards, we do have a public Slack channel at slack.bridgecrew.io, or you can reach out to me on Twitter at MetaHertz. So today we're going to kind of look at why infrastructure as code security in the first place. It very briefly, it might be a little bit too well known for some people on this call, but I always find a bit of context doesn't hurt. We'll look at some of the tools available. We'll look at some of the different personas in Kubernetes and kind of why it's very hard to enforce security on Kubernetes as a single thing because of the different kind of personas and users. And then just generally look at kind of what we're doing here at Bridgecrew and what open source tools you can take away today to kind of, enable that security journey and kind of give yourself better security posture for your Kubernetes deployments. So first of all, why infrastructure as code security? But no one is using the cloud by clicking around, unless you're discovering a new technology, unless you're kind of, discovering a new feature or a new product in a cloud provider. You're not going to be using the UI. You're going to be working with the cloud providers APIs, and more it's going to allow you to make sure your environment is repeatable and auditable. So if you have Terraform or CloudFormation, or pick your infrastructure as code language, you're going to be defining your resources in that format so that you can make sure if they've changed. You can go back to a previous configuration rather than having to remember who's done what in kind of the UI. And as that becomes best practice, it actually adds a layer of kind of extra complexity and extra risk because in that cloud provider environment, working with automation that's taking, that Terraform, that Pulumi, et cetera, and every time you commit a change into Git or, GitHub or wherever you're storing that, it's going to go and make changes in production. That's going to start moving your environment quicker than kind of a traditional security team or traditional security tools were able to. Traditional security tools would bless a golden image for something, or would, go and test a deployment before it was moved from staging to production. If we're now moving from staging to production, potentially multiple times a day, that partly manual process just doesn't really have time to work there. And, on top of that, because we have, multiple clouds, because we have all of this stuff, because as you see, cloud providers are adding products and products and products by the day, there's no way that even kind of a security person embedded into your development team or into your infrastructure team is going to have all of the defaults and all of the security issues that day in the top of their head, ready to fix. Unless we start moving those issues into code as well, the security checks, just like we do with our application code, unless we have CI/CD pipelines that can start doing some of this for us and tools that help developers not have these issues in the first place. There's just too much in terms of security. It's too much for a kind of traditional security team, but it's also not something you can just go, oh, well, we've got a security DevOps person in the team. They can do all of that stuff. It needs to be part of that automated pipeline. What do you see commonly in things like Terraform, things like configuration? You see hello world. You see, I found a piece of Terraform that works to achieve my goal, setting up infrastructure or deploying my application. And that hello world example isn't going to be belt and braces secure, because otherwise it wouldn't make a very good hello world example. It'd be very complex. And that's not to say that, engineers don't make mistakes and people don't disable security to try and, get things to deadlines, all those human factors as well. But generally speaking, we do find kind of a lot of configuration errors in the wild just come from really simple examples that sometimes make it to production. And again, that's not the fault of anyone. You need hello world examples, but it's another example as to why you need something in your pipeline automated so that when everyone's sleeping, we can catch that automatically. So fix it. Let's actually do something about it, and let's do something about it in a Kubernetes focus. So the main tool I want to talk to you about today is Checkov. It's our static analysis tool for infrastructure as code security. And the idea behind Checkov is you can point it at Kubernetes manifests, Helm charts, Terraform, CloudFormation. It's a very simple install using Python, or you can get it in a Docker container. And all it's going to do is it's going to run your infrastructure as code, so your Kubernetes manifest, your Helm chart, your Terraform, against a built-in repo of 500 plus checks. And the idea with Checkov is you can do this as early as possible. You do this when this is still undeployed infrastructure as code, or a brand new Kubernetes manifest you've written while it's still on your local machine or while it's nowhere near production. And by doing that static analysis, Checkov can tell you, hey, things in this are probably going to lead to security issues if you deploy it. And it gives you that earliest possible chance to make some remediations. And so to test this concept, we've created a load of Goat projects. So CFN for CloudFormation, TerraGoat for Terraform. And the idea with these is they are purposely vulnerable. And I've checked one out here, but you can find them all in our GitHub at github.com/bridgecrew.io. The idea with these is it's a load of infrastructure as code, which has been designed. So here you can see, for example, an EC2 instance on Amazon with Amazon keys embedded in it. Here you can see elastic block storage volume, which isn't encrypted by default. We've got public S3 buckets. Everything that would give your security team nightmares is in TerraGoat. It's not designed to be deployed to a cloud provider, but it's designed to highlight some of the issues you can find and fix early, with tools like Checkov. And the one we didn't write, which is the most important one for today's talk, is Kubernetes Goat. So lots of InfoSec tools, if you're creating purposely vulnerable examples, be it infrastructure as code or Python or frameworks like Flask or Node.js, generally the Goat projects are purposely vulnerable. And so the Kubernetes Goat is a perfect example. So we have that checked out here as well. And within Kubernetes Goat, we can find in scenarios some vulnerable, far too overly simplified Kubernetes manifests with a load of issues. And so what you do is you would open something like Checkov. Here we go. And you can see here, I'm running it against some Terraform, which spins up an EKS cluster. So here's our Terraform for spinning up an EKS cluster. And if I run that against Chekhov with Chekhov-file and just give it some Terraform, Chekhov identifies that as Terraform, and it will give you a load of issues it's found. So you probably shouldn't have your Kubernetes endpoint public at, for the whole internet. You probably want to enable secrets encryption for the secrets stored in your EKS cluster at rest. And then you can see all the other checks that we check for, which it's passing on this particular configuration, and then the ones that are failing, along with the block and the file and the line of code that matters. So yes, we can also detect CDK. What we do is exactly what you just said in the comment. We run a CDK synth, and then we scan the resulting CloudFormation. So we support CloudFormation, we support serverless framework, again, through the AWS CloudFormation it spits out. We natively support Kubernetes and Terraform and CloudFormation, and then Helm chart's the same. If you have the Helm 3 binary, we'll template that Helm 3 out for you when we find a chart, and we'll run the resultant outputted Kubernetes manifests against all the Kubernetes checks. So if we do a Chekhov list, we'll get all the checks that Chekhov supports. And it's worth noting, compared to kind of, people that might be doing admission controllers and needing policy packs with things like OPA, all the checks are built in. So if you get a new version of Chekhov via pip or brew install, or, you download the latest Docker container as part of your CI/CD pipeline, you just get the latest checks that are built in. So you can see we have 540 checks currently. And if we just grep for Kate, you can see we have a load of specific Kubernetes checks as well. Okay, so enough of Terraform, and I'll get to why that's important in a second. If we go to the TerraGoat repo, Kubernetes Goat repo, scenarios, and let's go into batch check. We can again run Chekhov with a file against this job, and it's going to give us some Kubernetes specific issues. And most of these align to the CIS security guidelines for Kubernetes. So you can see we're failing on quite a lot of things because this is a really simple manifest. Works great for a hello world, but there's a lot of things that realistically these should apply. So you should belt and braces, make sure the security context is set in your pod. You should run your containers as a high UUID to avoid conflicts with real host users, which start at in some OSs 1,000 or in some OSs 10,000. You should ensure seccomp profiles. You should make sure you are only mounting service account tokens if you absolutely need them. You shouldn't be deploying things in the default namespace. All of this good stuff that even if you just had this as a, awareness for developers, you might not want to fix all these. You might not be able to fix all of these. Knowing what issues you have against kind of CIS guidelines, in such a quick, easy way, is a great first step. And again, with everything we output in Chekhov, we provide the file name and the line numbers for a specific issue. So I kind of talked about Terraform just as much as I did about Kubernetes there. And so I just want to take a moment to consider the personas within, a Kubernetes cluster lifecycle, because infrastructure as code at a lower level is actually still important. When you consider Kubernetes, you have kind of two personas in my book. You have end users of Kubernetes who are going to be deploying their applications onto Kubernetes. So they're going to be deploying that, their actual line of business apps that are adding value onto Kubernetes. But then for every Kubernetes cluster, even if it's a cloud provided cluster like, AKS or EKS, you then have the persona of people maintaining that Kubernetes cluster. And they're also going to be writing Kubernetes manifests because, as a lot of you will know, because of the pluggability of Kubernetes, a lot of the parts that make Kubernetes run are themselves deployed onto the Kubernetes cluster as Kubernetes objects. So for example, CNI plugins, or for example, code to validate admission controller webhooks. All of that stuff is still deployed on top of the Kubernetes cluster, along with a lot of the time kind of maintenance and monitoring stuff. So like your Prometheus and your Grafana and kind of your stuff. So you have applications running there from one persona that cares about the business applications, but you also have Kubernetes deployments being done by, for tools that actually help maintain the availability of that cluster and the monitoring of that cluster. And it's those people that are going to find Chekhov very valuable for crossing multiple frameworks, because chances are, if you're maintaining, the Prometheus install on a Kubernetes cluster, or you're managing a third, Vault integration to do secret storage, you're probably also the team that's writing the Terraform or the CloudFormation to deploy and scale and maintain those clusters as well. So, being able to have a kind of a way of checking and writing policies and having these built-in policies across both is actually really important, even though this is kind of Kubernetes themed discussion. So the next thing I wanted to highlight on kind of our general dive into kind of Kubernetes and scanning things with Chekhov to find out, where the issues lie, what the commonalities are. You might be saying, well, I'm not a goat. I don't have such simplistic, manifests. I'm not purposely using vulnerable manifests. Like, where are my configuration issues coming from? And I'm just going to leave this up there for a second because everyone's done it. But aside from that, realistically, infrastructure as code is embracing reuse just as we do with application programming languages. So just like we will download a node dependency from npm, just like we'll download a Python dependency from pip, because we're not going to rewrite those things ourselves. We're going to use the modules available. We have exactly the same with infrastructure as code. So historically, we had the Helm hub for Helm charts in Kubernetes. We've got the Terraform registry for reusing other people's Terraform, because it saves a lot of time and effort and gets to business value quicker. And so in the same way, we need to be concerned about scanning our, third-party Docker containers that we import, in the same way we, care about checking for vulnerabilities. And, NPM, for example, does it automatically now, checking for vulnerabilities in application dependencies that we're importing from, unknown sources. We need to do exactly the same with infrastructure as code. And if you don't believe me, we took Chekhov and we automated it against Artifact Hub. So those of you familiar with Artifact Hub will know it is an open source CNCF project designed to be a nice API and web interface where people can register their Helm repos, Helm charts, and make them searchable by the community. Historically, Helm tried to maintain kind of a charts repo and had to manage all the pull requests and all that, whereas this is a more distributed view where if you have your own repo of Helm charts, you can go and sign up for Artifact Hub and register it there so it's searchable. So we took Artifact Hub, and using their APIs, we downloaded every repo and every Helm chart and extracted them and used the built-in capabilities of Chekhov to scan and template Helm charts to then scan the resultant Kubernetes and produce some data. And what we found is that across all of the Helm charts we scanned, about just under half of them had security issues that that Chekhov flagged up. Now, we did remove some spurious data from this, and we're actually about to release a 3-part blog post series and this data set and the code that we use to scrape this data set over the coming couple of weeks, kind of deep diving into not only the results and the data, but also how we took a couple of example repos and actually how we went through and fixed the Helm chart to pass all these. But I'm giving a bit of a sneak preview here. We scanned 436 repos with 1,713 charts, and just under half had some kind of failure. And while some of them, like I said, were you could say low priority, it's amazing how many kind of don't have CPU requests and limits, which means the Kubernetes scheduler in your cluster has absolutely no idea how to successfully scale, how to successfully restrict if you have a runaway deployment or an auto scale deployment. It has no idea how much memory that's meant to be using. So it will not limit that runaway process and could lead to issues across your whole cluster. Equally, security related issues. There are a lot of containers that don't have anything explicitly denying net raw capabilities or root containers or allowing privilege escalation. Again, cluster to cluster, there may be something you're doing with pod security policies that overrides that, but as a security posture of something that is being consumed by others, it's something we just wanted to provide some visibility on. And that's why we're going to be publishing the code and hoping to build this into something more permanent, where we can kind of look at giving Helm charts a kind of automated badge of health in the same way we do Docker containers and scan with things like Quay nowadays. What's also interesting from a data analysis point of view on this, and it might be interesting to some of you, the whole idea with reuse of code with Helm, it also just isn't quite there with the ecosystem, which we think could probably do with some work. So for example, given a small sample of the data set that we've graphed out, you can see here that we have 3 in green different examples of Postgres SQL. They are completely separate Helm charts maintained by separate people being used in different ways. And you can actually see here within this repo, we have 2 versions of Postgres SQL, which are actually being used by some of the same Helm charts within a given repo, but using different versions. We have kind of different versions of Redis. We have different versions of MySQL, Postgres. So there's no kind of, single place that we can all focus on to fix a given Helm chart, because there's still quite a lot of, multiple versions of the same things kind of in the Helm repos today. So I think no matter what technology you're using, it's all about, know your farmer, know where your chickens and your cattle have come from. I think Helm, because of its the way you can very easily create templates, and if you're familiar with doing that in another language, it doesn't really matter, but Helm would allow you to create a base template for a lot of your own custom Kubernetes, template that out so you don't need to keep rewriting it. Create yourself a secure baseline and then effectively use that elsewhere. Equally, if you know that you have done your own security analysis of some Helm, it might be a better place to start through it's supporting a third-party database service or some kind of third-party object you need in your application. I'm definitely not saying due to security, we should all write everything from scratch, because, there are thousands and thousands of lines in Helm written by the developers of a given application, which they have an interest in being the best way to deploy and maintain, their thing. So, choose your weapon as to, what and like your experience and things. Don't be put off Helm, but just, use tools like Chekhov. Use tools like Chekhov to kind of give them a bit of a sanity check first. Don't just blindly use configuration from elsewhere. Same rule as anything. I wouldn't let Joe give me a USB pen disk and plug it blindly into my Windows machine if I didn't know him. Same logic. So that was just a little bit on kind of exciting things we've been doing with Helm and kind of trying to get into the data of it. Like I said, we're gonna do something more with that. Not only are we gonna blog about it, we're going to try and turn that into a force for good, where we can have an API that actually gets you kind of a latest set of stats on a given Helm repo. So watch this space. I get to play with that as my next project. All I've done so far is show you a CLI tool. And, yes, that CLI tool is going to embed hundreds of policies, which, if you don't have a dedicated security person, or even if you do, is going to automate a lot of that work of what to look for and going through and finding issues. So hugely valuable on its own. But that's definitely not my takeaway from today. And the reason being is, as with everything that, starts life and then gets closer and closer and closer and ends up in production, within infrastructure as code, we see this paradox of the closer you are to production, the more information you have available to run security checks on. But the closer you are to production, the more time and effort and complexity it might be to fix that issue. And so what does that look like in a development lifecycle? And going back to those personas, I think this is the same whether you are the person that is building and maintaining the Kubernetes cluster, or the person just writing Kubernetes manifests for your application deployment onto a Kubernetes cluster. It's the same process, no matter which side of the Kubernetes fence you're writing Kubernetes or Terraform for. So obviously, a developer writing some Kubernetes manifests or some Terraform in their IDE, that's not being committed anywhere. That doesn't even have a commit ID in Git. That's not saved anywhere. That is an example of something that has zero complexity and zero risk of fixing. If you can find there is an issue then and there, it costs nothing. It's not deployed anywhere. You don't have to go and, add a new commit to go and change something. Kind of similar with pre-commits for people that maybe don't have the use of an IDE every day as part of their workflow. Pre-commit as a Git hook in your Git command will allow you to run tools like Chekhov to make sure that there's no vulnerable code in what you're about to commit as a Git commit. And, Chekhov supports that integration as well. So you can find the docs at chekhov.io or on the GitHub page for Chekhov. Again, running CI/CD pipelines as part of a pull request into GitHub or GitLab, or a merge request, should I say, another great place to put tools like Chekhov, because at that point, it's not at risk of being in your environment. It's not in master or dev or whatever your environments that are going to get automatically taken by your CI/CD pipeline and something's going to happen with them. You're actually able to provide feedback to the person. It might be an external contributor, it might be one of your devs. You're able to almost have Chekhov as that kind of virtual security assistant in your team, adding comments to a pull request through some checks going, hey, this pull request really shouldn't be merged. You've got these security issues, which could be bad if it got to production. And then obviously things we kind of take for granted as should have security tests in. So our CI/CD pipeline to provide that final yes or no gate before something gets changed in production. And then in production itself, you still kind of want to know whether something was secure when it was deployed, but a month, 2 months later, maybe someone's gone and done something manual at 3 a.m. that they forgot to document. You kind of want to know if something's changed in your security posture there. And the closer we get to production and in production, the more complexity and the risk of the fixes. Do you want to make manual changes in production? Do you want to wake up teams to rerun a CI/CD pipeline to fix an issue at 3 a.m.? It's a hell of a lot easier fixing things in the IDE, but it is important to consider running the same set of policies, especially where it's so easy through things like GitHub Actions, for example. There's no reason you wouldn't run the policies all the way through. So instead of just running Chekhov on the command line, fixing it properly, what does that look like? So as I've kind of hinted at, we have a kind of click and use GitHub action for Chekhov. It will find in your existing repo all of the things that we're talking about: Kubernetes, Helm, Terraform, and will provide you that CI/CD style green or red output. We also support annotations. So you can effectively use a Chekhov annotation in a Kubernetes manifest to say, hey, ignore this check, here's my reason, so that that annotation is stored in Git. Other developers can read the reason, but just like you would with any kind of security scanning tool for code, application code, there's always going to be exceptions, so you can do that. And also with the Chekhov command line, do type -- help. It's fairly full featured. We allow you to like import custom checks, ignore built-in checks, only scan certain checks, output in JSON, so you can then go and do your own thing and parse that output if you really wanted to. And the benefits of this is coming in the GitHub action fairly soon. You get annotations. So not only do you get the output of CI/CD, but you do have the ability going forward to kind of have your developers see something really easy like this as well. So right in their eye line, it's their day-to-day. They're in and out of GitHub or whichever Git tool they use. Having something like this, they're not going to check a security dashboard. They're not logging into a different pipeline. They're not doing anything. They're just getting this information that they're going to have some issues getting this pull request through. And alternatively, you can also output, like I said, in other formats like JUnit XML, so you can get a nice, for example, this screenshot's coming from AWS code build and code pipeline, which understands how to parse JUnit XML output from tools. So we have an output in JUnit XML, so it can generate this pretty graph with all of the issues for you as well. And like I said, the final piece to this, you can automate this really easily. The whole point of Chekhov is it is designed to do one thing and one thing well. So as I was kind of showing earlier, you can even just do -D and scan a whole recursively scan a whole set of directories for issues, and we'll find any of the frameworks we support and provide you a load of output. But also, it is designed to just be put anywhere you can automate. So any CI/CD pipeline, be it Jenkins, be it GitLab, GitHub, etc. It's pretty easy to deploy. The other thing that might be interesting, going back to that, every part of the pipeline, we also have a VS Code plugin, which is incredibly useful. You'll notice that same job.yaml Kubernetes manifest I was scanning earlier. I've already got the Chekhov plugin installed in VS Code, and you can see that it's actually giving me as a developer the same issues that it will fail with if we put Chekhov in our CI/CD pipeline and PR scanning in GitHub or the GitHub action. It's actually giving them me now. So I can click on one of these, which will take me to context for each of those issues. It'll give me, again, that kind of automated security member of staff, like just helping me understand what it is, why it matters, why it's being flagged up, and just allows me to kind of take a look at that right now, and allow us, to automatically generate annotation for skipping that if we had to. So we can add a reason there and be like, this doesn't apply because XYZ for future developers. And yeah, that works on Kubernetes as well. For things that are binary, it's worth saying, quite proud of this. So I'll show you while I've all got you as a captive audience. The whole team's worked hard on this. For things that are a binary decision, like we don't have to know whether your tagging strategy for annotations is X, Y, or Z, or we don't have to know which out of 6 secret encryption types you want to enable for your particular environment. For things that are literally like true or false, we actually support quick fixes through through VS Code. So if I applied this automated fix for ensuring data stored in the S3 bucket has versioning enabled, you'll see we actually understand Terraform enough to put the correct piece of Terraform into that block, so that issue then goes away. And we've got one less issue. And same for that one. So, again, just allowing a developer to kind of solve the problem before it's even saved, before it's even part of your code base. So yeah, do check out the VS Code plugin if you use it. If you use VS Code, sorry.
Just come through, mate. Sorry to interrupt you.
Sure, no worries at all.
Someone's asked, is there a repo with this sample? You want to use it to experiment with the structure?
Yeah, 100%. So all of our purposely vulnerable repos are at Bridgecrew.io, and they all have a Goat name. So we have TerraGoat for Terraform, we have CFN Goat for CloudFormation, we have CDK Goat for Amazon Cloud Development Kit. And then the other one that's worth shouting out, because it's an awesome resource, not just for infrastructure as code security, but also for understanding Kubernetes security in general, is the Kubernetes Goat. It's a really good resource. He's done an excellent job of building a load of documentation around it. There's recordings of him presenting it at other sessions. So as well as going and trying out Chekhov and the Chekhov VS Code plugin, definitely check out the Kubernetes Goat resources for all things security as well. And then the final piece I wanted to touch on is a little bit of a plug. We've talked mostly about open source, but it does kind of tie everything together really nicely. So Bridgecrew obviously maintains Chekhov and a bunch of other open source tools and Go projects. And we actually use Chekhov as part of our SaaS platform. So it's very much a build versus buy question. Do you want to kind of build a pipeline that integrates, VS Code and CI and pull request scanning and annotations and all of that together yourself? Or do you just want it to happen in a way that you have central visibility across all of your accounts, all of your Git repos? You can create dashboards and kind of check your security posture. And the reason I'm mentioning this is this unlocks, because it's always running, this unlocks things we can't do in pipelines. So at the very end of that diagram where we have runtime, Bridgecrew supports a load of cloud provider runtime. And this answers that question, hey, I know you deployed this Terraform, or I know you deployed this Kubernetes manifest, but what's really running in your Kubernetes cluster in runtime, or what's really running in your AWS account, actually isn't matching up to that. Like it's drifted apart, or there's been a manual change that has triggered the security policy. So the same security policies, but for example, what we can do is we can connect to a live Kubernetes cluster. And what this is actually just doing is creating a cron job, which periodically talks to the Bridgecrew platform's APIs. But it basically means that I can now see issues within my Kubernetes cluster based on those same issues. So here we see, for example, that, according to CIS guidelines, I have 4 containers running in my Kubernetes cluster, where the image is referenced as a version rather than a digest. So an attacker could change that tag if they got access to the repo and things like that. I've got containers that aren't running as a high UUID. So if there was a vulnerability for container escape, they could potentially assume a system user. I've got service accounts mounted in containers, which may be necessary. And I might want to annotate those and say, well, actually, this pod needs a service account. I've got containers with capabilities that maybe it doesn't need. Now, obviously, kube proxy, this is just a Docker Kubernetes local cluster for anyone interested. But, kube proxy is going to need cap net admin because it's reading and writing to pipes. But, potentially some of your applications won't, net raw, for example.
Is that the same in Azure and G-Cloud?
Say it again, sorry?
Is that the same in Azure and Google Cloud?
Yeah, so what we do, and I've created this account specifically for this Kubernetes demo, just to kind of separate the noise. But if we go to, let me find my actual Bridgecrew account. If we go to my Bridgecrew account here, you'll see we've got integrations with more stuff. I'm not sure I have an AWS account, so you might just have to take it from me. But yeah, here we see we have not only a load of Git repos that we're scanning automatically rather than having to kind of integrate pipelines yourself, but any AWS accounts would appear here. And yeah, it's as simple as, for example, AWS add account, launch stack. And if you're logged into an AWS account, which I'm not, that'd go and run a small amount of CloudFormation to give us a very limited set of read-only access to your account so that we could run the same kind of Terraform style AWS policies or CloudFormation policies against the real items running in your environment. Same for GCP, same for Azure. I just really wanted to show that kind of, one tool is actually very, very flexible through the fact that, we have these different phases of the development pipeline. And, having all of those policies checked at those different places yields different results. And what you can do with that today from, a one-off scan with Chekhov, just to kind of validate the security posture of Terraform or Kubernetes you're working on, right through to kind of installing the GitHub action and, you know, making it part of an official policy for your teams.